Hello and welcome to another video. To solve this physics question, we need to first understand this circuit diagram. We are going to use the circuit diagram to analyze the question, the problem. All right, now the diagram illustrates a 9.0 volt battery of internal resistance 0.5 ohms. This is the internal resistance 0.5 ohms, and the EMF is equals to 9.0 volts, connected to two resistors of 2.0 ohms and R ohms. So what we have is a parallel combination, a circuit containing parallel combination of two resistors of resistances 2 ohms and R ohms. So the 2 ohms and R ohms, which are connected parallel, are charged to a battery of EMF 9.0 volts having internal resistance of 0.5 ohms. Now, A1, A2, A3 are ammeters of negligible internal resistance. Ammeter is an instrument for measuring the flow of current in a circuit, and we can also use it for checking for the functionality of a circuit. So if A1, that is ammeter A1, reads 4.0 amps, calculate Roman numeral 1 equivalent resistance of the combined resistors 2.0 ohms and R ohms, and also to calculate current through A2 and A3, that is ammeter A2 and ammeter A3, and also to calculate the value of R, which is the unknown resistance. Now, like I said, we have a circuit containing two resistors of resistance 2.0 ohms and R ohms connected in parallel. Connected in parallel. When we talk about parallel combination of resistors, that is when we talk about the side-by-side arrangement of resistors, in a circuit. All right, so in this case, now we need to understand that the total voltage, the total voltage drop across the entire circuit, will be 9.0 volts. Now the total current, the total current flowing through the entire circuit is the current through ammeter A1. That is, if I write A1 will be equals to A2, plus A3. So which means that this will be I1 will be equals to I2 plus I3, and this is according to Kirchhoff current law. Kirchhoff current law states that the algebraic sum of currents entering a node will be equals to the algebraic sum of current leaving that particular node, which means the algebraic sum of currents at a point is equals to 0. So the current leaving, the sum of current leaving will be equals to the sum of current entering. That's according to Kirchhoff current law. All right, so we have here that I1 is equals to I2 plus I3. So which means this will be 4.0 amps equals to I2 plus I3. So we'll come back to this. Now, like I said, total current, the total current flowing through the entire circuit, which is I subscript T, is 4.0 amps. So the first thing we need to do is to calculate total resistance. So total resistance, total resistance, we need to calculate the total resistance. So from Ohm's law, we know that voltage is equals to I times R. So which means total voltage will be equals to total current multiplied by total resistance. So when we make total resistance the subject of the formula, so we have total voltage divided by total current. So the total resistance will be equals to 9 volts divided by total current, which is 4. let's not forget that the unit of resistance is the what? Ohms. So in this case, this will be 9 divided by 4. This will be 2.25 ohms. So this is the total resistance. Okay, now the equivalent resistance. This is the equivalent resistance. Equivalent resistance will be total resistance minus internal resistance. Let's not forget that there will be what we call lost voltage in this case. Lost voltage is the voltage drop across the internal resistance when current flow through a circuit, okay, and the current will not reach the external circuit. So that's why, so in this case, because it will not reach the external circuit, so it means that the equivalent resistance will be equals to total resistance minus internal resistance. So that this will be 2.25, okay, minus the internal resistance, which is 0.5. So that equivalent resistance will be equals to, now be equals to 1.75 ohms. So this is the equivalent resistance of the combined resistors 2.0 ohms and R ohms. And that's for Roman numeral 1. Okay, that's for Roman numeral 1. Now, Roman numeral 2. Okay, for Roman numeral 2, our task is to calculate the current through A2 and A3. Now, this is very important. The total voltage across the entire combination is 9.0 volts. Okay, now the total voltage, which is the EMF, okay, will be equals to, now we want to calculate, let me write this first. We want to calculate A2 and A3, okay? We want to calculate A2 and A3. So we need to understand that the EMF, okay, the EMF is equals to the sum of terminal potential difference and the lost voltage, okay, the lost voltage. This is I, and the lost voltage. So lost voltage is I multiplied by R, okay? Then we also have terminal voltage, also known as terminal potential difference, okay? That will be VT, okay? That will be I times R, okay? That's the terminal potential difference, also known as the terminal voltage. So in this case, okay, in this case, so we need to calculate the terminal potential difference. So the terminal potential difference will be EMF, that's E, minus the lost voltage, Now, terminal potential difference will be equals to 9.0, which is the EMF, 9.0. Now, the internal resistance, okay, the current flowing through the cell, okay, that's the current flowing through the circuit. That's the current in this case will be 4.0 multiplied by, that's 4 multiplied by 0.5. Okay, the point I'm trying to make is that now the current leave the cell. Okay, the current leaving the cell is the current through ammeter A1, and that is I1, and that is a 4.0 amp current. Okay, so 0.5 multiplied by 4, that will be 2. So this will be the terminal voltage, 9 minus 2, and this is equals to 7 volts. So 7 volts is the voltage across R ohms, and the voltage across 2 ohms, because now it is important to note that when it comes to parallel circuits, okay, containing resistors, okay, now it is important to note that the voltage drop across the individual resistance is equal. All right, so which means that the voltage drop across R ohms, okay, is equal to the voltage drop across 2 ohms. So which means that to be able to calculate I2 and I3, which is Roman numeral 2, Roman numeral 2. So we want to calculate, okay, we're on Roman numeral 2. So for I2, we want to know what is I2 and I3. Okay, what is I3? Now, so first, let me calculate I3. I3 will be terminal voltage divided by R3. Okay, terminal voltage divided by R3. So let's consider that R3 is equals to 2.0 ohms. So that this will be 7 divided by 2, and this will be 3.5 amps. So which means that I2 will be equals to, so from here, we're going to make I2 the subject of the formula. So I2 will be equals to 4 minus I3. So this will be 4 minus I3. So that I2 will be equals to 4 minus 3.5. So that I2 will be 0.5 amps. So therefore, I2 equals to 0.5 amps, okay, and I3 equals to 3.5 amps. So these are the values of A2, the current through A2 and A3. And when we add 0.5 and 3.5, of course, we're going to get the total current, which is A1. A1, that is the current through ammeter 1. Number Roman numeral 3. So now we want to calculate the value of R. So to calculate the value of R, that is, of course, we know that for these two resistors, okay, we know that these two resistors are, they are parallel, they are parallel, okay. So which means that because we know that the two resistors are parallel, so we can say that when the number, we can use the formula when we know that the number of resistors which are parallel is 2. So the equivalent resistance will be R1 times R2 over R1 plus R3. Okay, R1 plus R2 rather. Okay, so but in this case, okay, so this is when the number of resistor is 2. So now let's take R2 to be R, then R1 to be, of course, I use R3 in this case because we are looking for I3. So what I'll do is I'm going to write R3, okay, and I'll make this R2 so that this will be R3, then R2. So we can see that here, we can say that R2 is R ohms, then R3 is 2.0 ohms. So now we have the equivalent resistance to be 1.75 ohms. So this is 1.75 equals to 2 times R divided by 2 plus R. If you multiply this, this will be 1.5 times 2. That will be 3.5. So we have 3.5, 1.5 times R. 1.75 times R, this will be 1.75 R, then equals to 2 times R, this is 2 R, then we collect like terms. This will be 3.5 equals to 2 R minus 1.75 ohms. So 2 R minus 1.75 ohms, that will be 0.25. So this is 3.5 equals to 0.25 R. Okay, 0.25 0.25 R. Okay, because this is 2 R minus 1.75 R, then 3.5 will be equals to 0.25 R. So if you divide both sides by 0.25, if you divide both sides by 0.25, okay, if you divide both sides by 0.25, 5. So from here, so we have, this will be 3.5, okay, divided by 0.25 equals to 0.25 R over 0.25. So this is 35 over 10 divided by 25 over 100. So R will be 35 over 10 multiplied by 100 over 25. This is 10. 5 here, 7. This is 5. Then this is 2. 2 times 7. That will be 14 ohms. So therefore, Roman numeral 1, we are asked to calculate the equivalent resistance. So the equivalent resistance is 1.75 ohms. Then for Roman numeral 2, current through A2 and A3. So we have I2 to be equals to 0.5 amps, okay, and I3 is equals to 3.5 amps. 3.5 amps. Then Roman numeral 3 is to what? To calculate the value of R, and that is 14 ohms. And these are the answers to this question. The noblest pleasure is the joy of understanding. Bye-bye.